The video yesterday was put out about the new Lameness Locator that we have in the clinic. Fabulous piece of equipment, and we had a question of how does it work. So I'm going to take you through the parts and pieces of it, and then just run you through some individual cases that we've got that we put together and show you the output that we got and why we think it's a fabulous piece of equipment to have in the clinic. So the machine's made up of a few parts, so we're just going to break it down and go through them now and show you the different parts. So, like every good toy, it comes in a beautiful, nice, big black box. So we'll just have a look inside what we've got. So when we open it up, first thing you'll see is our mobile tablet. We've got that there, that's going to run the software on. And then we've got 4 sensors here. So there's actually 4 sensors we have available to us to put on the horse. Your horse has to wear a beautiful headpiece like this that goes over the ears, and that holds one of the sensors. One of the sensors then is wrapped on and put on the right front pastern, and that is important, it's the right front pastern. And then we use this beautiful clip with a pad that's stuck onto your horse that we can easily pull off, and this holds the sensor over the top of the pelvis, basically over the sacroiliac joint in place, and make sure there's no movement. It's really important when we attach this equipment that there's no artificial movement, that we make it as one with the horse. So those are the stick-on parts that we use to attach the horse. Then we've got 4 sensors. So I'll just lay them out here. We've got a head one, we've got the right front pastern, and even for vets they tell us to make sure that it's the right front, not the left front. So if you have got to know your right and your left. Then we've got the pelvis sensor, and we also have, which is a little bit interesting, a rider module. So we can actually measure the horse when it's been ridden, and we attach this to you as the rider if we need to. So 4 sensors that go on the horse, what do they do? So if we group the sensors together, we put them as 2 groups, and the reason for that I'll explain. This right front pastern sensor does not actually measure lameness as such. It tells the computer what stride we're on. So we're assessing the horse, the trot. So when we go back to basics, we know the trot is a 2-beat movement. So as the right front leg comes up, the left hind comes up, and the left fore and the right hind are weight bearing. That's really important when we're assessing lameness. Some lameness is visible at walk. That's a very severe lameness. Some lameness is maybe only visible at canter on certain movements, but majority of lameness, and by that majority I mean 95+%, is visible at the trot, and we use the trot to assess the lameness. So that tells the computer what's going on, what stride we're on. These 3 sensors then measure movement in space. So the head one obviously will be assessing the head movement. This will be the pelvis, and this is for the rider. So when we trot the horse up, it's really important that we do trot the horse up, A, in a straight line, and B, we don't want them to flick their head too much. So if the horse is pulling and trying to dance sidewards, I will sometimes use a mild bit of sedative to take the edge off the horse so we can trot the horse up and get a nice image. But those are basically the 3 sensors, and we attach those to the horse, and then we run the computer program in there. These sensors in real time are communicating with the computer, and we're getting output. So in real terms, it slows the lameness exam down slightly because we have to interpret as we go and we have to collect the data. But overall, I find the equipment really easy to use. So hopefully that explains what it is and the parts of it. I'll now go through and explain what we're looking for when we run the piece of equipment. So the Lameness Locator, this is a bit more of a breakdown of what the output of the machine is, but unfortunately I've got to take you back to physics to start with. So when a horse trots, the head comes up and it comes down, and then it comes up again as each foreleg lands and hits the ground and comes off. So the Lameness Locator, because it uses the right fore pastern as its anchor point for assessment of the lameness, we look at this here. So as the right leg starts to impact, the head's up, and then it comes down as it loads more, and then it comes back up as the left 4 hits the ground and comes down. So when we're measuring the output out of the machine, we're measuring the differences in height between this height and this height. So that's the diff max head, and then the bottom here, the green and the purple, is the diff min head, and we're measuring the differences. Now we know there's certain patterns develop when you have lameness in a certain leg. Equally, when the hind leg lameness is causing a front leg problem, you see similar findings as well. So there's a repeatable pattern between horses depending on the lameness. So the next one we go to, so what are we measuring? So in the forelimb, we get an output that breaks down the lameness into 3 components: an impact, a mid-stance, or a push-off lameness. Now, just to give you an idea of the sensitivity of this machine, the human eye can assess things about 20 times per second. The sensor runs at 100 times per second. So it's 5 times more information and data is being gathered by the machine than the human eye can. The human eye is still very important in assessing the lameness and putting it all together, but the machine does give us a lot more information. So each blue line here and each grey line is a stride, and the red in the center is actually the mean of what's going on. So what we're looking for, this grey circle in the middle, if the mean falls within that there, you can say this horse is normal and is sound and is not lame. So we don't need to worry about it. But as we look through different cases, you'll see things become more evident. But this is the output the machine gives us, breaks lameness down into right 4 or a left 4 lameness, depending on what the machine's picking up. So back to the first slide, we talked about diff max head and diff min head. So this is measuring the output, and this is what the machine tells me. 44 strides were assessed, and it's really important when we do use the machine to gather as many strides as we possibly can. And the reason for that is it reduces, when we go back to science and mathematics, when we're looking at means and averages, it's really important to get as much data as we can. So as a result, any outliers or abnormal strides can actually decrease the interference with the data and create a more normalized data set. So that's really important when we do look at that. So what are we measuring? Well, the right passage use only is the cycle assessment, does not measure lameness, where the head is assessing the lameness. So that's really important to have a look at. And also the pelvis is looking at this here as well, but in different setups. So let's have a look at the output. Not every horse is lame. And that is true, because some people worry about the sensitivity of this equipment will tell us that every horse is lame. One of the things we are finding is, and we're taught when we're using this machine, that you've got to stabilize a lameness. And by that I mean you want a repeatable lameness that you can trot up the horse and see that lameness exact same time. So sometimes when a horse I've turned up, we've had a chat, and then we've taken the horse for a trot either out of the stable or out of the cross ties, we initially will see some asymmetry or possible lameness. So it's really important to stabilize the lameness. Now we look at this output here. This is the hind leg output. I haven't quite taken you through that, so I do apologize. But you can see we get a push off or an impact changes. So any green line is impact lameness, and any red line is a push off soreness. Asymmetry probably is the best word to use rather than lameness. So this is when this horse was initially taken straight out and trotted out of the tie-ups. The equipment showed there's this red line up here that's just slightly outside the grey line. So technically, straight off the bat, this horse may have a slight right 4 impact lameness. But the one thing you will see is all these blue lines, it's quite a spiderweb pattern, so they're quite symmetrical, they're not all on one side, so that would tend to suggest that this horse is sound. The machine also gives a little bit of an output and interpretation of the data. No evidence of left 4 lameness, weak, mild right 4, weak, evidence of very mild, no evidence. Now these statements, weak, strong, moderate, are all based on the numbers that we've got out of here. How sensitive is the data, the standard deviation, and how concentrated is the data set. that's probably beyond this talk. But when we trotted this horse up again, and this is literally, I mean, turn the horse around, trot it away, the red line is nowhere near this grey border, but you can see a spider web pattern, and the horse is showing no lameness. No lameness whatsoever. So that's really important, that you have to assess that as a total thing. When we do use the machine, sometimes I'll ask you to trot again to try and stabilize the data if we have got any issues going on. So next, let's break it down and have a look at it. This is a horse that has a lameness. So you can see here, this red line shooting well out here to the right fore impact lameness. You can see all the blue lines are on the right fore. There's none on the left fore. It's very, very symmetrical, a right fore lameness. What the machine does allow us to do is when we start blocking horses and you've got multiple problems in a limb, it actually allows us to break it down a little bit. So this horse, we blocked out its foot, and you can see the change in lameness. So we've gone from an impact, a very strong impact lameness, to a milder mid-strand stroke push-off lameness. So that's really interesting, and this is where the equipment can be really helpful when we're doing lameness exams, to really assess the importance of what is going on. Now, the horse is not far outside the grey line, so whatever's going on higher up the limb, above the foot, is probably not the major thing. The major thing is in the foot, as we've seen here, big impact. So, we then went further up the leg. We did another block. So this is after we've done the right forefoot. This was very similar to the previous image that we've got. We then blocked the proximal suspensory, and you can see again the changes. We're starting to get a couple of left fore lines come in here. The red lines halved in size, and again very, very close. So this horse has got two problems going on. It's got a right forefoot and a right fore proximal suspensory. So that's interesting. That's where the machine helps us really diagnose and quantify what each part of the soreness is making in the overall output. So you can also lunge horses on this here. Now this is really interesting here. This is lunging on the left rein on a normal arena surface. You can see a very uniform spider pattern. When I block the right forefoot, you can see a very obvious left fore lameness. It's very similar, if you remember back to what the right fore lameness was. It was an impact lameness that we had initially, a right fore impact lameness. And you can see here, we've got a left fore impact lameness. So, like a lot of times, we've got a bilateral lameness, most likely both front feet. Now, this is the right fore lunge. This is before the block. You had quite a big impact lameness evident there, a lot of gathering there. We blocked the right front foot, and look at that. We're inside the normal line. The horse is almost sound. So a lot of stuff going on, gives a lot of data. We've also got hind end issues going on here, but we'll talk about that a little bit later. So what else does the machine do? We did treatment on this horse. We injected some things and we improved it. The beautiful thing about this piece of equipment is it's objective data that I can compare from the previous week to this week. So this is 7 days later. This was the initial exam. We had a very obvious right fore lameness. We tried this horse up 7 days later, really quite happy with it. And look at that. We've had a big improvement in the lameness. It's really improved and it's gone really well. So really super happy, and that's great to be confident that the horse is improving. This horse, the same horse, had hind limb problems as well, which we often see in older horses, hind limb and forelimb problems all married up together. I kind of ignored the hind limb lameness previously because I didn't want to use too much cortisone, so I just left it alone. It had a right hind impact lameness that was evident. I treated the front. We've come back 7 days later, and this here's improved. So the right hind lameness, part of it was due to forelimb problems and the horse loading up abnormality and putting stress on behind. So it's improved quite a lot. So it's done really well. So this is where the piece of equipment is really fabulous. Super excited to have it. And yeah, can't wait to show you guys more.